Hey guys, am I audible? Good afternoon.
Hi Dinesh, yeah, you are audible.
Okay. Guys, okay. Is that my screen is visible? My notepad
Yeah,
is visible. Okay, fine. Guys, what happened? The Docker, Alagarson said he has completed the Docker, but you have given some query related to that. But before that, I need to understand. So what do you understand from the term called Docker? So just you need to understand what you learned actually. So what is Docker, guys? Why do we need a Docker? Anyone from this group, can you tell me? Why do we need a Docker first? What is the one reason everyone they are moving from the traditional VM to Docker? Why Docker? Guys, I'm expecting one answer from you guys. Why Docker? The first question is I asked
it's
what is
a
Docker and why Docker? Yeah, tell me.
uh, it's like an application or an engine which
Mhm.
is installed in our system. Okay, and it's like a operating system, like virtualization operating system
Okay,
software.
okay. And Aman said it's a containerization. What is containerization, Aman? What is mean by containerization? What is mean by containerization? What is containerization? Can anyone tell me what is containerization? Packaging all software and application code. Packaging all software and application code. Okay. Okay. Good.
Like Docker containers are like lightweight in nature
Yes.
because they don't have the complete operating system. They just use the base operating system in
Mhm.
order to
Okay.
implement.
Okay. Okay. Fine. Right. Okay. No problem. So yeah, you are correct only. So I don't say it's wrong. Okay. But anyway, so let me tell you one example. Then we will talk about the Docker. See, listen, guys. Suppose Sadish is the person and he developed some application. Consider he has developed some application, a same gaming application. Sadish developed one gaming application. And right, this person, Sadish, wants to sell his product. So whatever the product, right, the gaming application which is developed by the Sadish, he wants to sell this product. Then of course, he developed this particular application, he wants to sell, but whoever the client or whoever the user or whoever the person they are buying, the buyer, right? I mean, we consider like a company X. They should have some precondition. What is the precondition? They should have this gaming application is developed for, consider this is developed for Ubuntu server. Consider it is developed for Ubuntu server. The dependency, I'm talking about dependency, right? So the library that is running, right? The dependency. I need a Ubuntu server and I need a basic Java 11 should be installed. And along with that, and maybe it should running on Nginx server. So which is 3.2 version. Like that, we have some basic need. Whoever wants to use this particular application, they should have the dependency like Ubuntu server, Java 11, and Nginx 3.2 version. The company X, I said, right? This company, they have liked very much. Consider like this company, they have liked very much the whatever the application which is developed by the Sadish, the gaming application, gaming app, he liked. But the problem is his machine, right? The server they are using. that server has only considered Red Hat flavor. They don't have a Ubuntu flavor. They have a Red Hat flavor, and they also have a Java 9 open source version they have. And yeah, maybe the Nginx, the basic server they are considered Nginx, the base model they are, base version they are. Even though this person, company X, this company liked very much this particular product, but they don't have Ubuntu server, they don't have a Java 11. Of course, you know, they can able to upgrade. Yes, of course, if you ask me, can I able to upgrade? Yes, we can able to upgrade. But what about the cost? We don't know, right? How many server they are utilizing? What is the reason they need only this gaming application? Because of that particular reason, they have to change the entire infrastructure, right? Yes, sir. Now, suppose if you take company Y, they have a company Y. The company Y also like this particular software, the gaming app. But again, they have a server, maybe a Java 9 they have, and they have a Ubuntu server, but still, Java 9 only they have, right? They don't have a Java 11. Again, they have to increase they have to upgrade. What about the cost? They have to make necessary changes on their infrastructure. When you change from Java 9 to Java 11, it will affect other software also. On server, there are different software, different component will be running. What will happen to those software? That also will be affected, right? This is the problem earlier the company used to do faced, right? So these are the challenges which is faced by the company in the maybe back in the days, 10 years in the 2010 or 2008, all the company they failed, you know. So they have to modify the entire infrastructure, then only they can able to run that gaming software in that machine, in the servers. Are you clear with this so far? Yes or no?
Yeah.
So this is the issue. This is the problem. We have to change our infrastructure to install this particular software. So that's the reason a new term coming to the market, which is called hypervisors. Can anyone tell me what is hypervisors? What is hypervisor? What is hypervisors? It helps to virtualize machine. Exactly. You are correct only. So hypervisor is also called as VMM. We can call it, which is what is VMM? Virtual machine monitor. Hypervisor, we can also call it as virtual machine monitor. So basically, it is a software. It's a software, or maybe we can call it as hardware, which is a layer, right? Using this, we can able to allow multiple guest operating system or multiple operating system or virtual machine, right? So using this hypervisor, we can able to allow, we can able to allow, one minute, can insert charger. Right. So what I said, so basically with this hypervisor is a software or hardware that layer, you know, which allow multiple operating system, allow multiple OS, or maybe we can call it as VMs, whatever you can tell, multiple VMs. Thereby we can able to run, you know, a multiple, right? To maybe if you want to run concurrently on a single, physical machine, single physical layer or physical computer, physical laptop, right? So where you can run a multiple guest OS with the help of hypervisor. So the main reason we are going for hypervisor is to provide a virtualization capability by abstracting and managing the underlying hardware resources. We have one laptop. On top of this particular laptop, we can able to create a multiple OS, guest OS. Do you know there are two types of hypervisors are available? There are two types of hypervisor. What is the one hypervisor which is called type 1 hypervisor, and the another one we can call it as a type 2 hypervisor. There are two hypervisors are available. Guys, the main purpose of hypervisor, it is a single physical hardware we have. On top of that, we can able to create a multiple guest operating system. All operating system we can work on individually. But remember, the first one, type 1 hypervisor, which is also called as bare metal. Bare metal we can also call it as. So using that, we can runs on top of the hardware directly. Top of the hardware directly. So type 1 hypervisor, it will be run on top of the hardware directly. So example, if you ask me example, if you take VMware, right? Did you hear this one? VMware SK. Or if you take Hyper-V. So this is two example or three more examples we have. This is an example for your type 1 hypervisor, which will run on top of the hardware directly. Top of hardware directly. AWS is not using the hypervisor. AWS is a cloud, right? AWS is a cloud. It has its own platform where on top of that they are creating, even though they are having the physical machine in the maybe in the availability zone or region, they are creating the different servers over there. We cannot say type 1 and type 2. Type 1 and type 2 that we are creating from our machine, from our server, from the local data center. Aman, did I answer your question? So remember, AWS basically where we have different versions, right? In underlying resources, which is region or maybe availability zone. So they are using their own hypervisors or own virtual machine. Through that they are creating. Do you know one word Zen hypervisor? Zen is the hypervisor. XEN. Zen hypervisor. So Amazon Web Service uses a customized Zen hypervisor for your only EC2 cloud. But other part of your block storage will be acting on a different hypervisor or different virtual machine which has been created. So no need to worry about, only I'm talking about the local machine. So as of now, we have two types of hypervisor. One is called type 1 hypervisor and another one is type 2 hypervisor. Type 1, which will be directly running on top of the hardware. But type 2, which will run on top of the OS install. OS install. Example, VirtualBox. Example, VirtualBox. Actually, in the 3 years back, I was working with the Capgemini. That time, we used the VirtualBox. VirtualBox, it is also one way. On top of the OS, you have to install this particular box. That way we can able to create the VM. Fine. So there are two types of hypervisor. One is type 1 hypervisor and type 2 hypervisor. Type 1 hypervisor example, bare metal, VMware, Hyper-V and all, which will be directly running on top of the hardware. But if you take type 2, which is running on top of the OS that we have installed. This we install. Any questions so far?
Okay, Dinesh.
Okay. So, right. See guys, in type 1 hypervisor, suppose if you have laptop, consider like if you have a laptop, you have a physical hardware, right? On top of that, you directly, inject your VMware. VMware here is the type 1 hypervisor, right? It's a type 1 hypervisor. VMware or Hyper-V. You will install. On top of this VMware, you can create what? Multiple VMs, right? You can be able to create multiple VMs. On top of the VM, we can introduce your guest OS. On top of this one, you can introduce a guest OS. So suppose if you need a Windows machine or a Linux flavor or a Mac flavor, you can go for this. But if you go with the type 2, here you have a laptop. On top of the laptop, you have an operating system got installed. This on top of the operating system, you are installing the virtual box to prepare VMs, right? Again, on top of the VM, you can introduce all your operating system. So here, your VMware directly we are installing on top of the laptop, but here the virtual box introduced on top of your operating system. So if you take both type 1 and type 2, so in the production server earlier, the company they used only a type 1 hypervisor, not a type 2 hypervisor. Only for demo purpose or small kind of operation that you want to play, right? Then you will go for type 2 hypervisor. But when you perform something on the production server kind of a deployment activity, you have to go for, then company used to go for type 1 hypervisor. It's not a type 2 hypervisor. Cool. Now, what is container? Now the company, they are not using the hypervisors, type 1 or type 2, it is not used, right? So we are all using the container. What is the difference between type 1, type 2, right? Type 1, which is directly running on top of the hardware. Type 2, it is running on top of the operating system. Thereby we can introduce the multiple operating system guest OS we can able to introduce. But the question is, what is container? Why do we need a container? What is container? Yes.
Yeah, it's a lightweight.
To host the image.
Okay, we have an image, that under fine. We have an image, we have a lightweight. That's completely acceptable. But why container? Why we are not going for hypervisors? Why container? Hypervisor, the one main reason why we are not going for hypervisor reason because cost. And second one, the spin up, like whatever the load that we are taking, right? It is from the hardware. So entire load it is taking from the hardware. Thereby the resource utilization will be very high. So that's the reason we are not going with the hypervisor. The cost involved is more. But why container?
It's a way of package application which will have all the necessary dependencies and configuration.
Okay, okay. What else?
Containers are just like machine, right?
Okay. It's a machine. Yes, container is like
Yeah.
an operating system also we can call. Mini
Yes.
operating system also we can call. Guys, do you know what is monolithic approach and what is microservices? Anything taught by Alagarison, sir? Monolithic versus microservice? Monolithic versus microservice. What is monolithic? What is microservice? Anything another since I taught you actually what is monolithic approach, what is microservice and all. Microservice, one part is divided into multiple pieces. One part is divided into multiple pieces. Okay. And the monolithic approach. So what is mean by name space, guys, in Linux? What is the namespace in Linux? No idea. Okay. Then we need to start from scratch. So we have to start from monolithic and microservice and everything else. Okay. What is meant by tightly coupled and loosely coupled, guys? What is tightly coupled and versus loosely coupled? What is the difference between tightly coupled and loosely coupled? Whether container is a tightly coupled or loosely coupled? Loosely coupled. Then what is the meaning of loosely coupled, Aman? What is loosely coupled?
Tightly coupled are like they are the dependents are the functions are dependent on each other.
Okay, correct. The functions are
And
dependent on each other, correct?
loosely, yeah, loosely are like not dependent. It is less dependent on each other.
Okay, okay, okay. You are giving. Okay, so I will tell you two terminology. It's an important entry question also. Remember earlier, back in the days, the company, whatever the application they have developed, right, that is following the monolithic architecture, guys. Or we can call it as monolithic approach, or even you can call it as monolithic. That's it. So here, guys, back in the days, one application, one server. One application will be deployed on only one server, or maybe a multiple server, one application. But remember, based on the capacity that will be deployed on to one server. So when you take a monolithic approach, where your application will be developed as a single, where your application will be developed as a single. What is the meaning of this line? Will be developed as a single, or we can call it as unified. Anything you can call unified. And also maybe we can call it as tightly coupled unit. Tightly coupled unit also we can call this. So whatever the application, say for an example, Amazon.in. That particular application has many components, right? Many components you can find it for that particular application. Say that application has user interface. That application has database. That application has middleware layer, right? There are many layers or many components you can find it in that particular application. But in monolithic architecture, all the components and the functionality of your application are bundled together, guys. And it will be deployed into the single code base. Suppose if they are developing the UI, they will use say for an example, base platform is Java. And then if you are developing the database, the base platform is Java. They will use some middleware. The base platform is Java. So there are more components, right? For application. Everything will be developed with the help of single code base and will be deployed into the single server. So in monolithic application, the entire code base, typically maybe we can call, right, it will be available in a single repository and runs within a single process. Suppose your UI required a database like Oracle. Your UI required Oracle. Suppose other backend layer. This backend layer require SQL. Can I able to use in the? Can I able to do this in the monolithic architecture? No, we cannot do. If you are using the Oracle DB, then backend layer or maybe other layers or other component also has to utilize same Oracle. They cannot change the database. They cannot go for SQL. They cannot go for Postgre. They cannot go for Redshift. They cannot go for other DB. So if you have a data access layer or if you have a business logic layer or user interface, all are integrated and it will share the same memory space, guys. Remember, they will get the same memory space. That's the problem with the monolithic architecture. That's the reason we can call monolithic architecture as tightly coupled. Monolithic architecture, we can call it as tightly coupled because whatever the component is available, like business logic, user interface, backend layer, data access layer, everything will be integrated into the single unit and it will be deployed as a single code base, single repository. Whatever the memory that is taking from the single place, not from the multiple places. So remember, here all your component will be integrated, which is tightly coupled, meaning that they have direct dependency on each other. They are dependent on each other. If you make any changes on one component, will it affect other component also? So changes to one component, other component or other deployment process, everything will be changed. So that's the problem with your tightly coupled application, which is called a monolithic architecture, which is company used to follow. Since all the components are bundled, right? It will be bundled as a single unit as integration is done. So the entire application needs to be replicated to handle increase the workload. Suppose if you want to do some scalability, if you want to do the scale out or scale it, so I have to modify everything. I have to modify everything. So is it easy task? If you ask me, no. It is very, very tedious task. Scalability is one of the prior problem. Already we have a tightly coupled problem. When one component is affected, other components also will be affected. When you want to increase the efficiency or when you want to increase the servers or reduce the server, it's again one tedious process. And as I mentioned, limited whenever if you go with the monolithic approach, you have to use the single code base. If you go with the Java, everything is Java. If you go with the Python, everything is Python. So only the specific technology, specific program language. We cannot introduce the new framework. We cannot introduce the new technology and all. Once you selected the monolithic approach. Right? So these are the few problems when company used to follow when they use the monolithic architecture. Am I clear what is monolithic architecture? Will you able to understand? Can you guys will you able to understand what I'm saying? Very simple. Monolithic approach means every application has multiple components. All these components will be integrated as a single unit. What is the problem with this particular approach is when it is tightly coupled, right? Everything getting the memory from the same storage space. So if you want to do some modification on your code level, will it affect other components also? And it is not a good, right? Say suppose for an example, you have developed one application. That application, if you require Java 11 or maybe some other dependency and all. So you must have the particular dependency. but other software is running on same machine, if requires this dependency, then what I need to do? I cannot do anything, right? Run on monolithic application. On monolithic application, one server or maybe two server, whatever that you are using, one application we can able to run it at a time. You cannot run other application. When you run, what will happen? Maybe that requires other dependency. When you modify, it will affect this particular application also, right? So that's the problem. If you go with a monolithic architecture, can you guys confirm, or otherwise I will repeat?
It is mono, like same, repeat with the same. It won't take any changes, right?
I'm not getting Jaya. Can you confirm? Can you quickly confirm?
I mean, like if we do any changes, it won't accept. It has to be the same configuration.
Yes. So if you do any changes on one component, right, it requires if other also got affected, right? Because other also got integrated with this particular component.
Yeah.
So monolithic approach, it is generally, whenever if you are okay, one application I can run it on one server, I don't have any dependency problem and all, then you can go for a monolithic approach. Back in the days, every company, they have prepared their application in the form of monolithic form only. But now the company, they have migrated from the monolithic approach. They already migrated from monolithic approach to microservices. When in 2014, the word came into the market, which is called a container. From the Docker, then the company used to follow the microservice. Now, we'll understand what is microservice. What is microservice? Guys, in monolithic architecture, the entire application is developed as a single tightly coupled unit. In monolithic architecture, the entire application is developed as a single, and it will be tightly coupled unit, right? But if you go with the microcircuit architecture, here you can break your application. You can break your application. Whatever the application, right? The gaming application, suppose you can able to break into smaller, and which is also a loosely coupled device. Which is also loosely coupled. Loosely coupled means, suppose if you are dividing your application into the multiple component, if you are dividing your application into smaller, each and every component got isolated. Each and every component, which is isolated. Thereby, in each component, you can able to run your application, which will not affect other container or maybe other a smaller part, which is loosely coupled service. So each service, right? Each service. So each service means like, say for an example, each service, suppose if you are running 10 services, consider like 10 services. Each service is independent. It is not dependent on each other. Each service is independent on each other. So you can independently develop, you can independently deploy, you can independently scale it. But if you go with a monolithic architecture, you cannot independently develop. One component, if you develop, other component will be affected. One component, if you test it, other component will be tested. One component, if you increase, other component will be affected. So here in microservices, we will create the multiple microservices. It means multiple services we will create it. Each and every services are independent, not a dependent service. Is it following Agile method, sir? Yeah, correct. In Agile is a process. Agile is a philosophy. The company, when they have a bulk amount of work, if you want to perform, right, they will divide their task in the form of sprint-based system, 2 weeks or 4 weeks. So Agile is a process. Microservices, I'm talking in the application level. So I have an application. The entire application, I'm going to deploy it onto the single server, and I have a multiple component already got integrated. This is a monolithic approach. But what I'm saying here, in application level, we can able to split into the multiple application. and all are loosely coupled. Here each and every services are independent, not dependent. So these services, right? These services, whatever the services that we are creating, they can able to communicate with each other. That's not problem. How? With help of APIs. How the services will be communicating with help of API. So there are different APIs are available. REST API, SOAP API. Like that we have many. That are well defined. Who has done that one? A developer already done that one. You don't need to worry about this one. How one services will communicate with other service. That is happening with help of APIs. Application Programming Interface. And suppose if you ask me, microservices, can I use a single code base? If you ask me, no, not like that. You can use it a different technology, guys. Different stacks you can use it. Different programming language you can use it. You no need to use a single programming language for all the component. Here you have a 10 component. All the components are independent each other. Then individual component you can create it with help of any languages. Suppose one component you can create it with help of Java, other component you can create it with help of Python. One component required Oracle, another component required MySQL. Then you can do it. That's what happening in the microservices. So if you want to do the scaling, the entire system will be collapsed right in monolithic approach. But if you go with the microservices for single service, suppose if you have one service, I want to scale out and scaling. Can I able to do? Yeah, you can do it. You have a one service or one component. This individual component I want to scale out or scaling. I can do with help of a microservice. Here you can do the scaling on a per service basis. So you can allow resources to be allocated based on individual service demand. Suppose one service required more memory, one service required more resources. Here you can allocate. That's not a problem. It's very flexible, guys. And remember, here when one service where you are making some changes in the code level, it will not affect other service. Right? Whatever the changes and update you are making on individual service, it will not affect the entire application. So guys, microservices provide a feasibility or scalability. Also, it is a development or maybe a deployment independently, you can do it. So here you can divide your application into the smaller and which is loosely coupled, thereby one service, it will not affect other service. Yes, we can be able to communicate from one service to another service with the help of APIs. That is already well defined. You don't need to worry about this. So that's the basic difference between monolithic and the microservice architecture. Monolithic, where you have single system, where we have a single system that should manage entire architecture, thereby it is tightly coupled, and one system will affect others also when you make changes on it. But if you go with the microservice here, all the services got not integrated, right? It is split into multiple services. Thereby it is loosely coupled. One service can able to talk with other service with help of API. Whatever the code changes you are doing on one service, it will not affect other service also. So if you want to individually scale out or scaling on particular service, yeah, we can do. Am I clear?
Yeah, Dinesh.
Any questions so far? What is monolithic and what is microservice? Fine. So in monolithic, we have group of component that will be considered as a single unit. But in microservice, the entire application, you can break it into the multiple services. Each services are tightly coupled. You have to remember. Right. So now how your microservices, which is helping your containers, how the microservices helping your Docker, how microservices are helping your Docker. Guys, back in the days, what is the problem we have faced? Suppose I have developed an application. If I want to sell the particular product, The end user or customer or client, they have to install the necessary dependency. Then only they can able to use my particular application. That's the problem. Then the entire server they have to modify. The cost is very high. And then the company they have moved from this one to light one and type to hypervisor. Again, the cost involved is very, very more. So when you go with the microservices Docker, both are complementary technology guys that work with each other guys, that work well together. So containerization. As you know, this containerization which is provided by Docker. Docker is one software. Docker is one tool. Docker is one engine. It will provide lightweight and isolated container. The word is very important. Isolated containers. And also it is lightweight. So lightweight. So who is providing this containers? Docker providing the container. Docker providing this container. So in microservice, individual service work with each other with the help of API. One service will not affect other service due to any reason. The same way, in this Docker technology, which uses the containerization, where all the container, you can create many containers on top of the Docker. You can create many containers on top of the Docker engine. Each container which is encapsulated, which container which is isolated with each other, which is individual microservices and their dependency. So each microservices will be packaged as a Docker container. Each microservices. Suppose I am running on application. That application built on top of the microservice architecture. Here we have more services, right? So suppose I have 10 services. Each and every services, each and every services, microservices will be packaged as a container. How we can package it? That we'll see practically. So here we will package into container. Each services we will package into the containers. So what it has? This particular container, it has something, right? I'm saying, hey, each services from the microservice, we are packaging into the container. What it has actually? It has the application code. Whatever the code which is developed by the developer, that will be available. That has the runtime environment. How we can execute that one? We need a runtime environment, necessary libraries or dependency. If you have any configuration, all those details will be available on your container. As I mentioned, the company all are following today microservice architecture. Here each and every component are closely coupled. Now this component will be made it as a container, packaged into a container. That container has application code, runtime environment, library, and all other configuration details. So that's called containerization. So using that, you guys can be able to deploy this container with a different environment. So you no need to worry about the underlying infrastructure. What kind of OS I'm using? What kind of hardware I'm utilizing? No need to worry about anything. You no need to worry about the underlying infrastructure. So suppose Jaya has one machine. I don't want to bother what machine Jaya is using. Aman is using another flavor. I no need to worry about that one because I am sending my container to him. Just container as all the application code, runtime environment, library, and configuration, which is isolated environment. So I no need to worry about your infrastructure and all. Simply I can install this particular software into your machine. Are you clear with this?
Yeah.
So I am already written the code. I already have a runtime environment. I already have a libraries. I already have a configuration that is running on my machine. Now, what simply I'm going to do? I'm going to package that into the container. that container, I can install it on or I can give it to you. So there, you guys will not face any problem, right? Because you have your own dependency that is running on your top of operating system. On top of that, I'm going to create what? I'm going to create one container. For that, we require the Docker engine and all. That's we are going to learn practically. We'll see. But as of now, are you clear with what is container? See, suppose I have my CentOS server, or maybe consider like I have a laptop. And on top of that, I have an operating system also. So what I'm doing, I am going to install my Docker engine, which is called Docker engine. So in software that I'm going to install. On top of the Docker engine, you can create multiple containers. Each and every containers are not tightly coupled, which is loosely coupled. Isolated environment that I'm going to make it. On top of the container, you can create your VMs. On top of the VMs, you can get any flavors. Whatever the application that you want to run, you can do it. So what's the purpose of container first of all? Yep, simple, to prepare the VMs. What's the purpose of hypervisor? To create the VM. Simple. Same container also to prepare the VM only. But what is the advantage here? Each and every container that you are creating it on top of your machine, Docker engine, which is isolated environment, which is loosely coupled because of a microservice. Because of microservice. Am I clear, guys?
Yeah, Dinesh.
So if someone is asking, what is Docker? Your answer should be Docker is one software. What is the purpose of Docker? It is to create a container. Your answer should be Docker is one software. Docker is one tool. Docker is one engine. What's the purpose of it? To prepare a Docker, to create a container. What is container? Container is a running instance of an application. Like EC2. Like EC2, you can take it. It's a running instance, right? Running EC2. So, but on EC2, your application is running because that has the application code, that has the running runtime environment, that has the library, that has configuration, everything it has, right? So containers are running instances. Containers are isolated environment in which your application is running. So remember, container runs in isolation. Whatever the changes we make inside the container, it will not impact the host operating system. It will not impact the guest operating system. Remember, suppose you have CentOS is operating system. On top of that, if you are creating one Docker container, will it affect your application OS? No, it will not affect your host operating system because it is isolated. So whatever the changes that you want to make on that particular container, you can make it. No issues. It will not affect your host operating system because container has its own IP address. Container has its own MAC address, right? Container has its own IP address. Container has its own MAC address. Yes, I'm asking you one question. Now, suppose your laptop, you have an operating system. Suppose that operating system needs an internet. How the internet it will be given to that particular operating system? What is the one component that we require to provide internet to that particular system? Can anyone confirm? Suppose my operating system requires internet. What is the one component which is dependent on providing the internet to the particular system?
IP address.
No.
Or
Yes,
internet
exactly.
gateway.
We need IP address. Exactly. We need,
Yeah.
but what is the component name? I'm asking component name.
Internet gateway.
Your laptop. I'm talking about your laptop. Your laptop on
Subnet.
top of the. Did you hear this word NACCON? NACCON. What is NACCON?
No.
That is what is NACCON?
No idea.
Okay. So NACCON. Others? network access control. Don't you hear this word? Network access control. So network access control card. So it is to connect your operating system. Internet, if you want to connect to your operating system, every machine has the NAC card. So NAC is the network access control or network access card. Using that, basically your operating system will get the internet. Fine. So remember, on top of your laptop, you are creating multiple, you are doing the containerization, you are creating a multiple VM. One VM, it will not affect other VM. Now, remember, so containers, basically, it is the running instance of your application. So which is isolated. Whatever the change that we are making inside the container, it will not impact the other host operating system because it has its own IP address. It has its own MAC address. In a layman term, I can tell container are miniature OS. Miniature OS. Miniature OS. A simple OS, small OS, which has everything, guys, of itself. And all the resources of the container. So, now you have a question, right? How this will get the resources? From where it will get the resources? From the Docker? No, it will not get the resources from the Docker. It will get the resources from your host operating system. Suppose you have a AWS cloud and you are creating one CentOS machine. You are creating one CentOS server. On top of the CentOS server, you are installing the Docker engine. On top of the Docker engine, you are creating the many containers. Using the container, you can create the virtual machine. Now, how you are getting the resources for this VM to run your application? You need a resources. Like where you getting? You are getting from the CentOS server. This CentOS server, we can call it as host operating system. So we have an infrastructure where we have a host AS and we have a Docker engine. On top of that, you can create a mini container. In container, you can run your application independently. Any questions so far, guys? Yes, sir. So what is the idea behind your Docker container? Self-explanatory. Remember, isolated environment. Thereby, you can run your application without affecting the underlying infrastructure or maybe other containers because it is a miniature OS. Now, whenever we try creating any container, suppose if you want to create any container, I'm asking you a question. Tell me, what is the one thing we require? Then only we can able to create the container. If you want to create any container, first Docker will look for what? What Docker will look? Yes, Docker will look for an image. So to create any Docker container, you first need an image. Without an image, we cannot create a Docker container. So what basically Docker will look? It will look for an image on your local computer. If it is not available, it will first check it on your local computer. You have a local machine, right? That local computer, it will look, hey, do I have a Docker image? If I have an image, I can run this Docker container. If it is not available, it will go for what? It will go for Docker Hub. Do you know guys Docker Hub? What is Docker Hub? Another sense I taught you. What is Docker Hub? Yes, sir. So initially, it will search in your local computer whether I have my image. If that particular image is not present in your local machine, what happens? Okay. So it will go for Docker Hub. Docker Hub, where you can see all your images. Dockerhub.com. So that Docker Hub, where it will download the image, and from the image, it will create a container. By default, Docker will look for an image in a Docker Hub. If it is not available locally on our computer. So whenever it is not available on our computer, it will go for Docker up and it will check whether I have a particular image in order to prepare that container. But we can also provide our local repository also. Suppose if you want to provide some local repository URL, also we can give it. So the Docker will check that particular URL whether I have a Docker. Say suppose I'm checking engines. So I have to log in actually. So better I can log in and I will tell you. I will create an account. Okay, guys, have you registered dockerup.com? Everyone? Have you registered dockerhub.com? Why guys you are not giving answer? Are you there? Have you registered?
Yeah.
Aman registered, Saran no. Register guys, complete that one. So simple process only. Click on register and give some username. I am giving some username, this one, and the email ID.
Dinesh, we can't see your screen. Maybe only the notepad you have shared.
Okay. Will you able to see now?
Yes.
Okay, you just give the registration. So this is dockerup.com where you have to register. Username or email address. Okay. So this is I will go with continue with free. Okay. I have to validate my email. So let me validate. Please give me a minute. Start. Verification is success. Fine. So now in this particular dockerup.com, we have many images. Suppose if you want to go for some Nginx image, press enter. I can see the what happened. Let me search in search bar or search Dockerup. Here Nginx. Can you see? We have a different images. So any images you want, you can get it here. Say for an example, I need some Selenium image. There is a tool where you have a Selenium images and all. Suppose if you need some, say for an example, CentOS machine. CentOS. Is there any images? Yeah, we have images. Like that in Docker up, we have a many images and you can use those images to prepare your container. So as of now, remember image, it is used to prepare your container. Am I clear?
Yeah, Dinesh.
Now, how to create the image? My question is next. How to create image? We can get the image from the local computer or maybe local repository or maybe from the dockerup.com. You know how to create an image, guys. How the people they are creating the image? How? How? Can anyone? So for that we require Docker file. To create the container, we need an image. To prepare your image, we have a Docker file. In Docker file, Docker is simple plain text file, guys. Plain text file without any extension. You will see Ansible where we have a YAML. YAML is an extension or YAML is an extension. But Docker file, it doesn't have any extension. It's a simple plain text file. So basically, this file has all the dependency. It will have all the dependencies to prepare an image. to create a particular image, we should have all the dependencies, right? That will be available back. That will be available inside the Docker file. So Docker file is a plain text file without any extension. It has all the dependencies. Without that, we cannot create the particular image. So in the Docker file, we have a dependency. Using that, we can create a Docker image. So there are two kinds of Docker image. One is publicly available. We can download it from the docker.com because that is public Docker images like Nginx, Jenkins, CentOS, Java, Python. All those images you can find it from the docker.com. But suppose in real time, we will go for our own customized image, right? If you want to create this customized image, then you have to go for Docker. You have to go for Docker file. If it is already well-defined image is available, you directly go for docker.com where we have a public images, you can download it. But in real time, you have to create the custom image. How to create the custom image? With the help of Docker.
Docker file.
So the idea behind using Docker, we can create multiple containers. Each containers are independent, isolated environment. How to prepare the container? If you ask me, how to create the container, we need a Docker image. Where you can get the Docker image? From the dockerhub.com. Dockerhub.com. But in real time, if you want to prepare a container, you need a Docker image, but it is not available in the dockerhub.com. Then you have to go for Docker file where you have to include all your dependencies. Then only you can able to prepare a Docker image. Then only there will be a Docker container. So there are two Docker images. One is public, that you can get it from dockerhub.com, or you can create the customized image. I hope you are clear with this. What is Docker? What is container? What is image? What is Docker file? Everyone?
Yeah, Dinesh.
Any questions so far, guys? Aman, Jaya, Kritika, Samved, Saran. Any questions so far?
No question.
Okay. Then we have to start the practical session then. Theoretically, almost we have completed, not completely. In real time, where the Docker file should be stored. So Docker file, they will be store it in their machine actually. Suppose if they are using, that will be definitely the secured place. Say for an example, LDAP. Did you remember I said LDAP? LDAP is one directory, right? Most of the production server using the LDAP. So through that also they have utilized. Or maybe somewhere also they may be placed. It is again company to company vary. We cannot say this is the particular location where they have a Docker file. Like that we cannot say. Even they will use it a GitHub also. They will use the GitHub to store this particular directory, but it's a private repository. No one will have the access. Only the employee they are working with the particular project they have the access. They will give it to you. They will add you as a collaborator inside the GitHub.com, and they will give you some access token. Using that you can able to access this a Docker file. So we cannot tell this is the place where we can have a Docker file. But using the Docker file, we can prepare some customized image, and using that image, we can able to prepare the container. Using that container, you can run your instance. Even did you remember in AWS, we have something called Amazon Machine Image, AMI. So using that AMI only we have created the application, right? Virtual servers, how we have created with help of AMI. The same way, here we have a Docker container. It is also a kind of AMI. Using that images only, we can able to create the virtualized server. Same, both are same. Find this. So let me stop it here, and we'll see the practical session tomorrow. But before that, tomorrow, please go through what is monolithic approach, what is microservices, what is the problem with hypervisor, why do we need to go for Docker container, what is image, what is Docker file, everything you should just to go through. right? Thereby tomorrow's session will be easy. No, Ansible is not completed, Aman. One more session is available. I will complete, Aman. If you have any question, you can ask me. Otherwise, we'll see tomorrow.
Okay, Dinesh. Dinesh, upload the video as soon.
I needed 2 hours, Jaya. I will upload 2 hours after 2 hours.
Okay, fine. Thank you.
Thank you, everyone. Thank you. Bye.